Kenneth, are you around? Did you join?
Yes, I am here, and I'm desperately catching up.
All right. All right. We didn't really go too far, so we probably didn't miss much. Don't worry about this. We were just very, we were going through stuff in a slow pace, but in depth. We were taking this kind of depth first approach, getting into depth. So if you could just run cells starting with weighted ensemble and getting up to the this cross-validation homework number 1. So this is where we stop. Before the homework number 1, or homework exercise number 1, which has the cell with the cross-validation algorithm in it, then this is where we are at the moment.
Perfect. Yeah, actually, I've run everything up, and I've just got to up to weighted ensemble classification. Actually,
Okay.
from the very beginning. So
Okay.
just in case.
Yeah, makes sense. Everybody else, Oleg here. Let's wait for the others. Once they start to switch on their cameras, I can see that they are present. Sandra's here. Igor, are you around? Simon, Lena. Igor is there. A nice T-shirt. Yellow color. Absolutely love it. Yeah. Lena is up there as well. Great. Lena, do you have any other, do you guys like, the stupidest questions are the most important ones. If you could, come up with the stupidest questions, I would be extremely grateful. I would be like super happy. You would make me a happiest person alive. You could ask questions like that, okay? No stupidest questions somehow came along for some reason. So the advertisement didn't really work out. Simon, how are you? Hey, cool. All right, so let's get started. We were just discussing that we want to have accuracies. So we want to have average cross-validation accuracy instead of weights here. Because we cannot really look at the test estimates and say what are the weights that we need to figure out. Instead, we actually do cross-validation algorithm to do it for us. That's what Alexandra said. It's one of the simplest approximations of the weights. This is the shortcut. This is how you get this kind of things. It's a shortcut. Yeah, so basically here we try to write up this cross-validation code. And this is where we left off last time, before we went back to the discussions about the cross-validation and all that kind of stuff, which were pretty much valuable. So thank you very much, everybody who were participating in these discussions. Now let's get back to this and try to understand what is it that we are doing. Oleg, can you remind us, what's the plan? What's the plan of this code? What is it that we are trying to get from here?
We are trying to calculate accuracy for every fold, yeah.
For every fold, for every model, right?
For every model, yeah.
Okay. How many folds do we have, are we going to have? Lena, how many folds do we plan to have?
4. Can you hear me?
I can hear you. I couldn't hear what's the first word was.
4 folds.
4 folds. We want to have 4 folds. So I couldn't hear that one. I've heard that you said 1. I wasn't really. I couldn't hear that. So 4 folds. Yeah. So we will have a for loop. In fact, not one for loop, but more than one for loop. So the most general for loop, what is it going to loop over? Igor, what do you think this most external for loop will be looping over? What is it that will be the most external part of the loop?
Well, I think we need to calculate accuracies for each model and for each fold.
Exactly. Yeah.
Well, I think we should do this by folds, and then in the body of the loop, we should do this model by model, like that.
Well, we can do this way, or we can do the other way. I think I prefer somehow looping over models because it just somehow feels more natural to me. But I think you're absolutely right. You can do first by folds and then by models. It just feels to me that I need to do less at first. I don't like to do stuff, so I'd like to have stuff that we already have. Since we already have models, we don't have folds yet, right? So we didn't really code anything about folds here. We only have models. So I prefer to loop over models. So if I just say for every model in models, do something. I like that. It just reads nicely. It's just easy to read. Let's go on. So Simeon, what are we calculating? So this print statement is supposed to give us some kind of information about what is it going on here. So what is it that we are calculating for stuff? What is it that we are calculating for?
I think we are calculating average accuracy for given model.
Accuracy for given model, right? So here's the kind of a dilemma, because what if I write, Lena, what do you think happens if I write model here? So since I loop over model, so models, and for every model in models, I do print out this statement here. I can comment out this once, by the way, for now, just to comment them out. So what do you think happens if I really loop over and I print out the object model? What happens? Any guesses? Okay, let's give it a shot. It gives me out a lot of scikit-learn, I would call it B words, but basically not important, useful, useless information. So I don't really want to see this stuff. What is it that I can do to print out something useful? Any ideas?
You should take property.
So which one? Which one? Let me first give you one thing. There is a function called enumerate. If I'm not wrong, I'm not sure if it's np enumerate. So I go into Python enumerate. Okay, this is the enumerate in Python, and then what it does actually, it gives me besides. So what I say is that for index and model in enumerate models. So this enumerate models produces not just a model that I can loop over, but also index of the model that it loops over. So I can just say, I can write index here. So I know what is the ordinal number of the model that I'm looking at right now. So if I do this like that, it would just calculate the average accuracy for 0, 1, 2. I can say, well, model 0, 1, 2, that would make sense, right? So I just would know that I'm getting through model number 1, model number 2, model number 3. I can also add +1, and then it would be actually normal human numbers, like model number 1, model number 2, model number 3. Make sense? Ladies and gentlemen? What else can I do? So Oleg mentioned attribute, right? Did you say attribute?
Yeah, property attribute, yeah.
Property. So what kind of property can I output here? So how do I know what are the properties? Lena, how do I know the properties of the object?
Dir.
Dir, yeah. So I can write up here. What is it that I'm looking for? Ladies and gentlemen, what is it that I'm looking for? What is it that would be interesting to kind of output?
Type of classifier or
Type of classifier. How do you think it's the, what would be the kind of name of the property that we would be looking for? Lena, what would be the name of the property?
Score.
Score? If we are looking for the type of classifier.
Um,
So we are working with decision trees, KNN, and logistic regression, maybe something else. And we want to know that this is a KNN and decision tree and so on. What kind of property we might be looking for?
Maybe decision function or solver.
Okay, maybe.
Maybe get name, something like this above.
Maybe.
No, get name.
Estimator type.
So basically, there are versions, but I think there is also something called name. I think there was something called name or model name, which I think would be more appropriate. I can't see it at the moment, but I'm pretty sure I remember that it had something like this. So basically, you could output something more useful instead of just index. But let's just get back to index here. I have to, okay, so there is one.
Excuse me, do you want us to repeat the code together with you, or you will copy this code to the message?
Yeah, I think you can copy it, or you can type it as well, or it's up to you. Basically, I will probably do it for a long time, so it might be quite boring to watch. So maybe you want to do it as well, or I could copy this here and then. So I just, okay, so this is the current state, okay? I need to open, let's say, give me a second, I'll just, okay. Since I deleted a lot of code and now it's gone. I don't know what was happening here. We can try to do it together. Okay, resume sharing. Do you guys still see the cross-validation code?
mm-hmm.
Okay, now what needs to happen here? Okay, cannot copy the code. Okay, that's nice.
The deleted. That's the deleted stuff. I put the deleted stuff.
Okay, thanks. This is useful. What happens now, Oleg? What happens now?
So now we need to go through the folds, yeah.
But how do we get folds?
We had, I think we had a constant with number of folds.
Well, we have 4 folds. That's true. We need 4-fold CV. But how do we break data into folds?
Yes, we need to break it to get indexes for first 3 folds where we want to train and 1 fold where we want to validate.
Yes. So we want to have a way to somehow say which of our data train images, which images belong to which fold, and we will have 4 folds. So we need to break things into 4 folds, the entire training data into 4 folds, and they should be equally sized folds. So how do we do it? How do we break the entire training data into 4 folds? Simon, any ideas how to do it?
We can calculate the length of the training set and divide it by 4 to find the
images. What about this one? Divided by 4. So this is the size of the fold, right? This is the size of the fold. Yeah. Now, how do I break into folds? So Any wild ideas? How do I make folds of size 500?
Use scikit-learn, it will do for you.
Oh, you know what? You will do it in homework, exercise number 1. You will do scikit-learn function.
I did it already.
You did it already in this homework exercise.
I mean, I did it in previous home exercise.
Oh, in the previous homework exercise, you should have done it yourself. So not scikit-learn, but with your own, these hands, no scikit-learn. Scikit-learn is the superpower. You have to earn the right to use superpower before you use superpower. So by these hands, how do you get the folds by these hands? By just, you know, dun, 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 dun. Okay, what if we do it like this? What did I create? Lena, what did I create just right now?
Array.
Lena?
Okay.
Array of what?
This folder size.
Of fold size, which is 500. So I created 500 onces, right?
Mm-hmm.
Do you see what am I getting? No, not yet. Okay, anybody, does anybody see what am I getting? Simon?
So we should, instead of 1, we should put our points from training set.
Then I will have 500 times 2000 training sets.
Yeah, of course. We should put next.
Okay, let me show you another iteration of this thingy. What if I do like this now? And then like this, and then like this.
Actually, indexes, yeah, for your folds.
Yeah.
And then I can do something called concatenate, just to make them into one large array, right? So if I would output 0 to 100, well, 100 is not enough, probably. 1000, okay, it doesn't really output because it's so large. Yeah, so basically I created, I think I called it folds indexes, right? I called it like this.
But you shall start with 0.
No, I think I can start with 1 as I'm pleased. I can do whatever I like. I can just go through 1, 2, and 3, and 4. I'm happy with that. I can start with 0, that's true, but I'm okay. I can start with 1, 2, and 3. What is it that is still necessary here? Or not necessary, but is somewhat, okay, so what am I, okay, let me copy this over here. So this is how I create folds, fold indexes, okay? And this is what Kenneth has copied over. He has actually copied this. Now, what I could do is I could just say...
We need shuffle, yeah? So to make it really random.
Yeah, so we need shuffle. So how it works is that I type random and then shuffle, and then I put in here this one, and I don't need to assign it back to the folds indexes. It will just shuffle inside. It would shuffle inside. If you don't trust me, let's do it like this. So I do it here, and then I print the fold indices, let's say 0 to 200. So you can see it here, right? So what I want to do is I want to do something like this. I will then say fold indices equal to, let's say, 1. And what do I get by this? Lena, what do I get by this? What would be the output of this? Lena, I can't hear you. I can't hear you. What is it happening here? What is it happening? Say something, at least something. Where did it got, where we lost you? And which place? This place. Igor? Is that, are you following?
Yeah, I'm following. So the question was, what
happens?
Yeah, we will have like an array of two with true and false when the item in array equals to 1 and the item in array doesn't equal to 1. So in this case, we can get like indices of 1 and then use them like for our purposes.
Yeah, exactly. So these are the indices of lines in our input in our training images that would belong to the fold 1. And if I would click over, I would use this and say, well, these are the indices of the fold 2 images, and so on and so forth. And I would get 500 images that would be randomly shuffled across the training data, which is what I want, right? Any questions about this? Leon, what is it confusing about this part? What is it that doesn't make sense? Everything? Okay, think about this, because you need to implement it.
Elegant. Yeah.
No, it's not. I think what you were using, the scikit-learn, is more elegant. Why is it not elegant, by the way?
I mean, elegant if it's done, let's say, manually, yeah, so without some library.
Yeah. So, Kenneth, are you with us?
Yeah, I am with you. I'm reproducing what you're doing, and at Foles index, I get telling me a falseness in my array, so I'm trying to kind of catch up. But no, I'm paying attention.
So does it make sense what we are doing here?
It does somewhat, I guess.
Somewhat. Ask questions.
I think I'm not even ready to ask questions.
Okay. Then as soon as you're ready, then please shoot and ask questions. Okay. All right. So, ladies and gentlemen, let's get back to the main code. So here we shuffle the folds indices. What is it that we have to do next? What is it that we have to do next, Simon?
You have a
party there.
My children are crazy next to me. I cannot unmute.
I think I can hear somebody else, not just children there.
Yeah, I think
Oleg, what do you think is happening here?
Oh, fabulous.
Fathers, yeah, it's that's what study when you have family is all about. That's fun. You study not just yourself. Oleg, what is it that we need to do here? When we have this is randomly shuffled finally, what can we do?
We need again to iterate through the so actually we need the first 3, yeah, to get begin and end. This will be our training index, yeah, of first 3. first three folds. Yeah.
Blah, 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 blah. I'm not sure I got it.
So we need really start and end indexes. Yeah.
Start
We
and
need
end indices of what?
For training.
But we
data.
just take three folds and the fourth one is out. So we just, you know.
In principle, yes. We can take say okay, we take beginning of first index, end of third index. This is our training set, yeah. And we also need to define validation set, index set. This is a fourth index, begin and end.
Yeah, but I can just say I just need a number. I just need the number of the index of the fold, and I'll get all the indices. Okay, but Igor, yeah.
I think we can go folder by folder. So
fold by fold.
Yeah, fold by fold. We can build four folders, and the number of folder will be the number of the folder to be excluded from the training test.
Yeah, exactly. So we can have
from 1 to.
So here we have, let's say, indices of folds. These are 1, 2, 3, 4. Yeah, these are folds indices. So these are number of folds that we have, basically. That's all. And then we can have so we have here folds indices. We can have here fold index just to make sure that it's singular. And then we could say, okay, since this could be a fold that would be taken as a validation fold, right? Now we have to create train and validation sets. I mean, we can call it train X and do something, and then train Y and do something, and then validation X and do something, and validation Y and do something, okay? What is it that is going here? Lena, what is it going to this train X? What is it that's going inside here? Okay, let's put it the other way around. What is going inside validation X? Since we now have fold in this, we can finally create a validation set, the validation set for the cross-validation algorithm.
We should take all indexes folder 1, fold index from the training image. This is it.
Yeah, so we just have to say these guys equal to this guy, and that's pretty much it. That's how we get training images that have indices that align with the number of the ordinal number of the fold that we're looking at right now. So we're just saying, okay, these guys that we have generated here, they have 2000 values shuffled, 1s, 2s, and 3s, and 4th. Now tell me, what are the positions of all the ones that have this fold index as an index, okay? And now I'll get 500 of these values, okay? And this will be my training images. Sorry, I take them from the training images, but now I call them validation X because I'll use them for validation for this cross-validation iteration. Oleg, what should I type? What should I type here?
Oleg is not here.
Oleg is not here. Elena, what should I type in here? So I got this validation X, but all the other folds should go into train X.
Like the same, but fold index will not equal to.
Yeah, like this, right? So exclamation mark equal, so which means not equal, right? All the same, but not equal. So I select all of the images which index does not equal to the fold index. I can actually call it maybe validation fold equal index so that you guys, it make more sense. Would that make more sense? Okay. What about the train Y? Lena, what about this train Y here? What is this, for example, first of all? So if these are images, train X are images, what is train Y?
Labels.
Yeah, labels. So I just take train labels, labels. What should I type inside?
Like the same for X.
Yeah, this the same stuff, right? Same stuff. What should I type here?
The same for validation X, but with labels.
Yeah, exactly. Exactly. Absolutely. Oh, that's been hard. That's been very hard. Nice. We now have training data and we have validation data. What are we doing right now? What is happening right now? Igor, what is happening right now? Can you help out? What is happening? We have training data. We have just generated training images, training labels, validation images, validation labels. What can we do now?
That's easy. We can train and validate.
Exactly. How do we do it? Can you help?
We should fit our model with training data. All models, I think. Maybe
Yeah.
one.
Well, we could do it by one model at once because we are looping over models, right? So we can just take and say model. Then what should I do?
Fit.
Fit, exactly. What should I fit it on?
Train data.
Train X, right? Versus train Y. This would be our labels. Okay, this is going to fit train the model. What should I do now? What should I do after this?
We can really validate. So we can take output of the models for accessing validation. And
I can also use another method called how do I get accuracy without really taking predictions and then comparing to true values and that kind of stuff?
I don't remember this val function, no?
No. Somebody posted.
QF.
OF?
Score.
OF?
QF. No?
Score. Lena was right. Score. Lena, what should I type inside?
Mod. Okay. Array. Okay. X and Y. Validation X and validation Y.
Yay! You get it. Oops, I didn't get it. Sorry. Right. So what is it that's going to do? This will give me an accuracy on the validation set of this model that we train here. Okay. Now the problem, we need to store it somewhere. We need to keep it somewhere. So we need to create a separate variable. We'll call it fold accuracies. And what's the size of these of this variable? Okay, that makes sense. How do I put this into there? Lena, how do I put this into there?
It's the same with like 0, blah, blah.
Yes, zeros. How do I, what I put inside here?
4.
4, perfect. It's getting great. Now, I should be somewhat, so I get this fault accuracies, NP0s 4, which means that I'll get the array of 4 filled with zeros. perfectly fine. Now I should somehow write something inside here so that I put the validation accuracy to the right place. Ladies and gentlemen, what should I write here? Kenneth, what should I write in there, inside the square brackets?
So something to make some coordinate-wise addressing of these results. So I'm not sure how you would do that precisely.
Yeah. It's not easy, definitely. Igor, can you help? What is going inside this square brackets here?
Well, this is 4 items in fold X, so we should input well-fold index, I think.
Okay, well-fold index. There is one caveat though. What is this caveat? Lena, can you see the... Sorry?
It should be -1 because...
Exactly. It should be -1. Lena, do you know why it should be -1 here?
Because you started from 1, not from 0.
Yeah, I was stupid enough just to say I want to have 1. But obviously, a normal Python programmer will never do that, right? Because then you would have to do this ugly thing, subtracting -1. But you know what? I'm ready to go for this because I don't like starting my folds with 0. I don't like zeros in that sense. Okay, so great. Whew, that was a journey. We have written a lot of nice code here. Well, yeah, let's not show it on PyConference or something like this, but it's a nice code. So what are we going to get by the end of by the end of this code running? What is going to be the result of this? Simon, are we done, basically? What am I asking, ladies and gentlemen? I'm asking you a question, are we done? Is it all? I'm shouting like inside the institute building. I hope there is nobody on Saturday.
So in this for, you mean? In this for?
Yeah, in this for loop, are we done?
So we take the data, we train the model, and we write the result in the array. So it seems okay.
Seems okay. Seems fine. Seems fine to me. Yeah. I guess there is something that might be missing. Is just based on. I'm not sure if we should be somewhat more cautious about fitting models many times on different folds, because I'm not sure if this might be just basically somewhat retraining the model. This could be retraining the model, which is something that we don't want to have. Let me Google this. Reinitialize. Learn. Reset the model. Oh, it says both base clone. That's fine. That's fine. Let's see what happens. It doesn't matter. What should be done outside the for loop? So there are these 2 print statements that I kept from previous version that I can uncomment. Is there anything we should change inside here? Lena, is there anything I should change inside these 2 lines?
You need to.
Can it?
Yeah, fold ACK is now fold ACCS.
Yeah. Anything else? Anything else, ladies and gentlemen? There is one more difference.
Index for model index +1.
Yeah, it's model index. It's model index, and it also here index. Now it should be done. It should be actually fine. Let's see. Yeah, so this is what we do. We just take the average of fold accuracies. We output the indices +1 just for the model. And yeah, we record it. We record it. So let's see what, oh, chain labels. Train labels was misspelled. Okay. 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 So these are the results. So let me copy it to Slack.
I'm
so
getting
this is what,
errors.
you got errors.
Indenting errors, which is the worst kind of errors.
Oh, don't worry. Just copy this part, because there might be error in terms of how do you address the places. So it could be the problem. But otherwise, just don't worry about this. Do you guys have questions about this code? We have been working on it for like an hour now, I guess. It should be kind of clear what is happening here. Lena, do you get how do we kind of created this fold indices? Because I saw that you followed the other parts, but I think this was the challenging bit. This was a little bit like off the grid.
If we would like to create not for fall, for wall, so we need to create, for example, so can we use n folds, like variables, and then use instead of for? So
you have pointed out the weakest point of this code, because no, you can't easily do it in here. Actually I pointed it out in here in this line here. I was just saying that this is a very strange line here, and there is no easy way to make it into 5 folds and more folds, but at least you're right in the sense that we can have end fold equal 4, and then I can insert it into all the right places, like here, and then here, and then here, and here. Oops, this is not there. And this is here. There is one problem though in here. How do I make it work? I need to use a function called np_arrange. It's called np_arrange. And then this inside. This will produce something similar, but starting with 0. So I need to make sure that it starts, I mean, as you like. But this requires a little bit of code tweaking. And if I would need to produce more folds, it would still need more tweaking. So I'm not happy with this code. That's why I made this homework exercise number 1, which says that, can you guys do exactly the same stuff? But now instead of using this awkward, ugly, crooked line here that we have made together, you could use a nice and nicely working function called stratified k-fold. And it does have some nice parameters inside, and you can get those folds much quicker and much simpler using this for loop, which I've written for you. So this does exactly the same stuff as before, but now instead of creating this ugly monstrosity, you can do it with a stratified k-fold. Okay? So this is a homework exercise number 1, is to go back and instead of using monstrosity, use the library and the function stratified k-fold. Do you guys have questions? Anyone? I'm really glad, Lila, that you actually could follow the other parts and not focus too much on this bit that was a little bit kind of weird. It was crooked and it was weird. So I'm sorry for this. If you guys don't have questions, then there is even simpler way to do it. So instead of writing your own function with stratified k-fold inside and then still looping over and then collecting the accuracies and that kind of stuff, this has been done tons of time by millions of people, and people that they don't like to do repetitive things. So they basically implemented this in the function called cross-val score. where you just say how many folds you want. And here I'm just saying cross-validation equal to 4. And then you have X and Y, and then you have model 1, model 2, model 3. Here I sent train images and train labels as Y and X. I refer to them as X and Y. And I just run these. I run that, right? And this is what I get. 0.7, 0.883, and then 0.8835. So basically pretty much the same results as I get here. 0.7, 0. Around 90-ish, and 0. Around 90-ish as well. Any questions? A silence, a holy silence. So this one line here is an hour of suffering by 6 master students and 1 me. So this is just one line, okay? What is important is that this line does not have shuffling inside. Does not have shuffling, ladies and gentlemen. Simon, what does it mean? What can be the trouble if there is no shuffling?
It means that so not shuffled data set means that could be biased. So it means that before using this function, we should shuffle that data set.
So what could be? I mean, what could be the data set for which this could be a trouble? Can you elaborate on this?
For example, cats and dogs, when in first part of the data set, we will have much more dogs than cats.
Yeah. For example, you will actually see an example of this happening very soon when we generate our own data and the first 50 lines are all belong to the class number 1. Then basically when you take the first fold, the entire fold consists of the first class. This is not great. This is not good. So that's why you need some time to shuffle it. So how do you shuffle it? You say here stratified K fold, and then you do the same stuff as you did before, but just like you say shuffle equals true. Okay, but in this case we don't really need this, so I just use CV equals 4. Any other questions?
Yeah, if you put this this shuffle, this statement you just deleted. Yeah, how the formula knows that we should split by 4 folders?
Oh, you also say it here. So this, I think, is somewhere here. You say 4, and then you say shuffle true, and then basically this gets into CV, and then this cross-validation score knows that this is the type of fold splitting that it should use.
Thank you.
Any other questions, ladies and gentlemen? Does it all make sense? Lena, so now that we have these values here, can we now finally use them as weights?
We can try.
Yeah, we can try, absolutely. In here, I also normalize them, but this is definitely not necessary. It's not compulsory, it's not necessary. I just wanted to visualize, remember we had weights that Oleg put into the previous example. Do you remember what were the weights? Lena, can you tell me what were the weights that Oleg has?
0.2, 0.4, and 0.4.
So these are the weights that Oleg gave us, and these are the weights that we have right now, okay? So these weights are more conservative than Oleg. So Oleg was a bit more, how do I call it? Energetic, maybe optimistic, maybe. So I use these scores. Now, can you please guys use these scores, so weights, this weights, inside the voting classifier down here below in this cell to reproduce the weighted ensemble and tell me what's the accuracy of this weighted ensemble. So where should you put this variable weights so that the voting classifier knows what are the weights for your models?
Weights and weights.
Yeah, weights equals weights, right? And then we can run it. Yahoo! So we got 89.2. Simon, do you remember what was the accuracy that we got before? Was Oleg's more energetic estimates?
Think about 87.
No, 88.2 or something.
Yes, 88.2, exactly. So
2 hours ago.
2 hours,
2 hours ago. Yes.
Because I am 2 years younger. That's why I can remember this.
Okay, that's an internal jokes here.
I mean that Oleg made this calculation with low accuracy, but 2 hours ago, you know.
Ah, yes, the time value.
Yeah.
That's why I was frightened by Oleg 2 hours ago.
That's right.
You guys, you guys have Oleg's contact, so now you wouldn't have to implement it yourself, and you can just text him and say, "Hey, can you give me weights for my models?" But the thing is, having written this once, you will be able to rewrite it for no time and get the +1 accuracy over Oleg's predictions. So that is worthy. That is worthy. Oh, nice. Finally, I can get back to slides. I can actually get back to my slides, and you guys may still ask me questions if you like. Huh? Any questions?
Hello, guys.
Hello.
Do you hear me?
Yes.
Sorry, I have an electricity shortage in my house, so I reconnected with mobile internet. So that's why I will be mostly muted and without video.
Mm-hmm. Got it.
But if you can ask me, and then I will answer. Yeah, but
okay, gotcha. Hope that they will fix it very soon. I recognize Ukrainian realities. Do you guys see my presentation view, or you see a slide?
Presentation. Oh no, slides, I guess. No, well, kind of both.
So you see both the current slide and because it's
current slide.
It's a presentation mode. It's like what is supposed to be seen by you.
Okay.
By presenter, yeah.
Okay. This is not what I wanted. Okay. Okay. Now if I do this, no, it's still like that. Weird. Let me try to. It's just today I'm using this. What about now? It's one slide without the presentation here.
One slide.
Okay, good. All right, so we discussed that ensembles, even in today's practice session, we discussed that ensembles work better when they have different models that are part of this ensemble. So more models different, better the ensemble. That's you need the diversity to make ensembles work better. Do you remember what did I say yesterday about training models and making different models? What did I say about this stuff? How did I refer to training the same models, the same 3 models, and getting slightly different results? What was the reason why I got different models at the end of the day? When I take the same, for example, deep neural networks, and I train them on the same images, how do I get slightly different model performances? Anyone? Lena? No? Kenneth? You take 3 deep neural networks.
Yep.
You take the same images.
Yep.
But at the end of the day, you get slightly different models. How does it happen?
Oh, because the networks are different stacks inside.
Yeah, but why do they have? Because we had the same images, so wouldn't they train to be the same?
Oh, there's a certain stochastic effect. So there's a certain randomness that happens. But would you not create these networks to be slightly different, with slightly different stacks, different activation functions, or
Yeah.
Presumably you would deliberately to be as different as possible.
Maybe dropouts played role.
Maybe dropouts played role, maybe some other stochasticity, but also you initialize them differently, right? So when you start these models, when you create these models, you initialize them. So you initialize the weights from the random distribution, and that's how they can get very different in their performances. So that's how you can get different model performances. Okay. What are the other ways to make different models? You can take conceptually pretty different models. You can take a deep neural network, you can take a decision tree, you can take a linear regression or logistic regression, and these would be quite different. What could be the problem with this approach? Simeon, what could be the problem with this kind of approach? When you take a deep neural network and then you decision tree and then some kind of logistic regression, what could be the problem with this? Interpretation could be the problem because they definitely work using completely different premises, very different assumptions. They make very different calculations on the data. So the interpretation could be a problem. Any other problems?
But those don't sound like problems. Those sound like what you want.
No, those sound what you want in the sense that they will work differently, right? This is what we want at the end of the day. But interpretation is also something that we want because we need to know what exactly, sometimes we want to know what machine learning algorithm had in mind when they made a decision. So this would be trouble because in fact, we are not working with one machine learning model, but we are working with 3 and they are conceptually very different. So it would be kind of hard to make our minds about what was exactly going on there. So this could be a problem, but what other problems could be somehow associated with this approach? Think about, so deep neural networks, they work with images, directly with images, but decision trees do not work with images, they work with vectors of values, right? Logistic regression similar. So sometimes actually having this very different, conceptually different models could be inconvenient because you need different inputs. Data that should be transformed differently, should be pre-processed differently. For example, for using images, you can do augmentation for the deep neural networks, but then for the logistic regression, it might be harder to do the augmentation. If you do, for example, use PCA before you feed into the logistic regression. So it could be slightly inconvenient to use very different, conceptually different models, okay? And moreover, the other problem could be, what if we want to use the same type of model? For example, some kind of decision tree that would be deterministic, but still on the same data. So it turned out that we can play around a little bit with the data, and we may use not all of the data for training. So we could, for example, use resamples. So we can use, for example, 70% of the data, another 70% of the data, and then yet another 70% of the data. And this is called bootstrap data. The process is called bootstrapping. We use these bootstrap data for the same model. So this could be a model which has exactly the same weights. It has been initialized once, so we have just one model. We copy it 3 times, and then we train it on different bootstraps. These are called bootstraps or resamples. These are called either resamples or bootstraps of the same data. And then we get different models because they were trained on slightly different data, okay?
Would sequence have an effect? If you took the same data and you fed it front to back into one and back to front into another, would that have a result in the end? And presumably it would, because of the way back propagation works.
Yeah, so
Or does it average out?
it depends. In principle, yes, this would also result in slightly different models. Yeah, but probably in this case, it would result even in more different models. So I think this, you can also do it the way you are saying. So you can also break it down and shuffle differently and that kind of things. And that would also impact the model, the final model weights. Any other questions here? No? Okay. Then I have a question. How is it different from cross-validation algorithm? Lena, how is it different from cross-validation algorithm?
Like for cross-validation, you use the same data. For bootstrapping, you try to resampling, like to make it different, something like this.
So in cross-validation, you use up the entire data, right? In Bootstrap, you actually extract 70 or 80%, however have you. Let me visualize this. So here is the bootstrapping. This is what we discussed. You just take and make resamples of your original data set. So you have 100%, and here you have 3 batches or 3 portions of the same data with 70% of the original data. In the cross-validation algorithm, you take this 100% of your data, you divide it into folds, and then you use up these, you use 2 folds for training, the other one for validation, but eventually you end up using the entire data each time you do these cross-validation iterations. In bootstrapping, there is no strict division into folds. You don't really care about the folds. You just get the items. You get the 70%, 80% of the items. In the cross-validation, you actually separate the data into buckets. In bootstrapping, missing data is not used at all, so you just lose it, right? The 30% that was not selected for each of the bootstraps, it's not used in any other way. In cross-validation, you actually use this not selected data as a validation data set. Does it make sense, ladies and gentlemen?
Yeah, it seems less good. I mean, one of
the bootstrap.
Yeah. I mean, the major goal of every course we've ever taken is to try to get as much good data as possible. And here we just throw some away and don't use it.
Yeah, but the thing about, I mean, I can try to defend the bootstrapping here, saying that, but they overlap. The bootstraps overlap. So it's not that these are the unique 70%, and then the other, you can't really have 3 times unique 70%, right? So, Oleg, your light is back, right? Electricity is back, great. So what I would say that bootstraps actually use your data in a very efficient way because they overlap. And since they overlap, you overuse some of the data points many times. And that makes it somewhat nice in that sense.
So why not bootstrap, overlap, take the stuff that left behind and use it as a validation fold?
You can do it. The problem is if you take the validation, so let me explain why we do bootstrapping, then you will see why you can't use this for the validation fold, okay? Do you also, other guys, do you have questions about this? All makes sense, crystal clear, nothing to write home about, easy peasy lemon squeezy. Okay, good. So training on different parts of the, on different bootstraps produce diverse models, or so we say, so we assume it produces diverse models. What happens then is that we get the validation data image, we put it through the models, right? And then we do, so we predict dog, and cat by 3 models. So each model predicts a class for this validation image. And then we do a good old majority vote, right? So in this case, Olena, what would be the majority vote?
Dog.
Yeah, just to wake you up. Dog, of course, dog. This part is called aggregation. With a majority vote or averaging, what have you. This is called aggregation. So when you do bootstrapping plus aggregation, you call it bagging, right? So you do bootstrapping and aggregating. bagging. So these bootstraps are called bags. So one bag, the other bag, and the third bag. These are called bags. And I will illustrate how exactly bagging works using a good old decision tree algorithm. Do you guys remember the decision tree algorithm from the first lesson, very first lesson that we had? So the decision tree algorithm, it asks questions about the value of the independent variable and tries to make assumptions and predictions about the value of the dependent variable. We had a lot of fun trying to define what's the split in this case, and what would be the good predictions of the fair amounts of the right values on the left and on the right of the split. And I remember Kenneth was pretty quick at saying that we need to take averages. And so this was the time when we worked with the decision tree algorithm as a regressor. So we've worked with the decision tree algorithm when we try to predict the price of the ride. If you take a taxi or taxi at the middle of New York, we try to predict what would be the price of your ride based on the distance that you go, okay? Sorry. But now we are working with the decision tree algorithm as a classifier. So now instead of having independent variable, the dependent variable will be the class. But X1 and X2 will be both independent variables based on which we will make predictions. So previously we used X-axis as independent variable and Y-axis as dependent variable that we were trying to predict. Now we will use the color, the third axis, which you don't see, the shape and the color. So we will try to discriminate between squares and circles using X1 and X2. Does it make sense? Ladies and gentlemen, please shoot your questions. Oleg, now you have the freedom, you have a battery, you have energy. Please shoot questions.
X1 and X2, what is this then?
There is no interpretation for like a specific value, but
okay.
You can think of this as, for example, distance that you go, and then X2 could be a time of the day when you called it, and red and the blue could be whether you get a red taxi or a blue taxi. Ta-da! That's it.
Okay, some abstract. Okay.
Something abstract, yeah. Now that, so yeah, basically we are asking questions about values of X1 and X2 and trying to predict a class, 1 or 0. Now, here's an example. We have X1 more than 4.5, and then the class is 1 if it's false. So all the values all the points on the left of this split will be considered blue, and all the values on the right of this split will be considered red. Okay. So this is a vertical. Sorry, this is a horizontal split. Let's call it a horizontal split because it splits the horizon. And this is a vertical split. So this is an example of the vertical split. Or would be better to say it horizontal. I don't know. Seriously,
I'd say horizontal.
This is horizontal. Let's call the green horizontal. So the green one is a horizontal. This one is a vertical. So the horizontal split is basically, this is an example of the horizontal split. Just an example, just an abstract, absolutely random example. For example, X2 more than 3 is the split. And then everything that is above the line is considered to be red, and everything that is below the line will be considered to be blue. Okay. We can also make somewhat mixed decision tree, so you can have both vertical and horizontal splits. For example, we can combine both of these trees together, and we can have a first a root node saying that here is the split on X1 of 4.5. So everything to the right of this split will be considered to be red. Everything to the left of the split will be considered to be blue. But then inside of this right part, there is another split, which is a horizontal split, which is saying that everything that is above the line will be considered to be red, and everything that is below will still be considered to be a blue. Does it make sense, ladies and gentlemen? Any questions, please? Stupid questions have a priority.
All good.
All good. All good. Okay. That I believe, Kenneth. And then let's go on.
It's a stupid question. So
Sorry.
that I'm in charge of the stupid questions.
Oh, you're in charge. No, I'm sorry, man, but you are in charge of smart questions. But this is not a priority now. We need more stupid questions in place. I'm all for stupid questions, more stupid questions. And you know what? When they ask stupid questions, it turns out that these are the smartest questions you can ever ask. And this is what drives me mad. They keep them for themselves, and then it turns out that these are very important questions that should have been asked way ahead. Yeah. Anyway, so what we are going to do right now, we are going to apply bagging to learn tree decision trees. Ladies and gentlemen, now all the magic, all the dark magic starts. We're going to apply bagging to learn tree decision trees. So what do I mean by this? Lena, what do you remember? What was the first step in bagging? What was the first thing that you need to do in bagging?
Random some data.
Here's your data. These are 5 points. So what should you do with it? You need 3 decision trees. What is it that you're going to do? So bagging is a word that has 2 parts.
Bootstrap.
Bootstrap and
Aggregate.
and aggregate. So what bootstrap, Lena, stands for? You have 5 points. Anybody wants to help?
Take 70% of the data.
Yeah, so I gave you this number, 70%, but it actually could be different for any other data. So here, I actually, for example, I take 80% of the data.
4 points.
Yeah, just to make it round, because 70% wouldn't be nice. So I took 80% of the data. Lena, what happens? So this is bag number 1. What happens now? What is on the next slide? Imagine yourself in the Что, где, когда program. And the guy is asking, what is on the next slide? The time is ticking.
No, 50%.
Why 50%? You take equal number. You take equal amount of data.
Yes, 60.
It says 80%. Why 60? Why 50? You get the same size. You just take another random sample. You take another random sample. Okay? Igor, are you still there? Man?
Yeah.
How are you doing? Can you say what is on the next slide?
Next slide.
$100.
Yeah. Another 80%.
Exactly. Another 80%. So this is what the bootstrapping stands for. When somebody is saying with a smart face, they look at you and they're saying bootstrapping. And they think that you will not understand what they're saying. So what they actually saying is that I took a random generator and I selected 80% or whatever number of percent of my data into separate sets. That's it.
And the number of bags is equally a random, or like not, or is 3 is kind of a term of art?
It's an arbitrary value. You're right. It's an arbitrary value, but you should. So think about this way. If I take an even number of bags, then I will have troubles merging these stuff, right? So I need to take an odd number of bags. The number of bags means the number of decision tree or whatever classifiers that I will train on top of these bags, which means that more bags I have, more time it will take to train. Also, it's somewhat determined by how much data do I have, because if I get like 5 points, then generating 100 bags doesn't really make sense, because maybe 80% of them will have the same data.
Yeah. Okay. Yeah, I understand. Yeah.
So it's not a completely random number, but it's somewhat arbitrary number, because you need to determine it by what is the size of the data that you have, what are the models that you're going to train, and that kind of stuff.
But typically it's like 3 or 5 or something.
3, 5, 7, 9, something like that. Yeah. Any other questions, ladies and gentlemen? Your questions. Okay. Now, what happens now? What do you think will happen now? I want you to guess my slides. I want you to foresee what is going to happen now. Lena, coming back to you, what do you think happens now?
Train models.
Yeah, we train the model. Which bag do we, okay, but I mean, this is fine. Okay, we train the model, right? So we take the bag number 1. So this is a bag number 1, which has red, blue, blue, red, right? So it's in the upper part that we miss out this, I don't know if you see my cursor, but it's basically rounding up the shading, the point that is basically faded into the background. We don't have it. In this bag, there is no point like that. So what we do we build the first decision tree based on data in the bag number 1, right? We build it based on the bag number 1. Do you guys remember what you need to do in order to build a decision tree? What is the first thing that you need to do to build a decision tree? So here's the battlefield. You have X1, X2, and you have 2 classes. What is it that you need to build a decision tree?
Depths of the main parameter, as far as I remember, is the depth, yeah, of tree, or how it's called.
No, it's let's think. Let's just say that we will be using depth 1. So this is hyperparameter is fixed. Good. What else do you need?
You mean like programmatically or just like conceptually? What to be?
Conceptually.
Orders.
My instinct is towards those averages and to kind of look at like imagine where those lines would be, where those dividing lines is.
Exactly, where the splits are, right? Where the splits are. So the first question is, what are the possible splits, right? What are the possible splits for the decision tree? Can somebody, not Kenneth, tell me where the possible splits? Lena, so I will, on the next slide, I'm giving you a head start here. I will show lines that will separate points. Where do you think these lines will pass? What would be the places?
2.5, 3.5, 4.5.
2.5, 3.5, 4.5, and?
And 5, 4 point, okay, sorry, 4.5 by x2, like horizontally.
Oh, yeah, that makes so much sense. Do you guys understood where the lines will go? Okay, so let's see. I wasn't as smart, so I just started with the first axis. I started with the vertical splits. Now Kenneth can say, rightfully can say, you know what? The first and the last line are completely useless, and he would be absolutely right. Actually, on the next slide, I'm not saying this, but I'm basically saying, I'm asking whether anybody is smart enough to find out that you can also make a split on the horizontal line. Of course, Lena already said it, but here I just make sure that you guys understood it, because X and Y are both playing part in this game here, so we can split both by X1 and X2 values, right? And again, here I'm just giving all possibilities. Okay, all possibilities. But as we just discussed it makes no sense to use these lines, right? So these lines do not make much sense because they do not split the data. There's no way it splits the data. It leaves all the data on one of the sides. So it doesn't really make sense to even consider these. So all we left with these 4 lines. So these are the 4 lines that we are left with, okay? Make sense? Anybody questions? Okay.
We could have less lines if we got rid of the horizontal line and got rid of the 3.5 line. We could do it just with 2 lines.
Why would we? Why do you think we should get rid of these? Oh, you looked at them and you're like, oh, but that doesn't make sense because it's equal number of things on one side and the other side, right? Yeah. So you were quick just to look at the.
Yeah, the lines are separating things that are in the same class.
Yeah, that makes sense. Completely makes sense. But imagine that we are an algorithm, so we can't really see it. So we are humans, we can see it. But from the algorithm perspective, these are still valuable possible splits, which may still be worth it. So we need to really calculate something for it. How do we evaluate the splits? What's the way to evaluate the splits? Lena, what's the way to evaluate? Oh, wait, sorry. Igor, you are missing from my matrix of people, so I can't see the square with the name Igor. Igor, how do you evaluate the splits?
Evaluate, well.
Yeah, so how do I say which one is the one I should go for?
Which one is the one? Well, I have no idea. I don't know.
Okay. Lena, do you think, what's the way to say which one is the one in here? The best one, the one that we should choose for the tree. Okay, let me put it the other way. You have somehow figured out that these are the splits that we need to consider. Looking at these splits, do they all look the same way? Are they all equally good? That's what I'm asking. Are they all equally good?
Probably not.
Probably not. So how do you know that? What is the intuition? How do you get this kind of feeling that some split is maybe better than the other split?
You could test the accuracy of each split.
Yeah, you can calculate the accuracy of the split and just, figure this out. Look at the accuracy. All right. So we can compute the accuracy of the split. For example, let's concentrate on this accuracy. Oh, sorry, on this split here. Let's say that with this split, we will consider everything that is on the right to be blue and everything to the left red. What is the accuracy of this split? Simeon, what is the accuracy of this split? Everything to the right is blue, everything to the left is red.
75%.
Yeah, this was the wrong person to ask. He just shoots the number and you never know how this number turned out to be. Can you explain how this 75% materialized?
I see that there is one group of red and, and two correct answers for blue.
Okay.
So all in all, we have 3 correct answers, and we have 4 points. So it is 3 to 4. It's 75%.
Makes sense. Makes sense to me. So 3 over 4, 75%. Great. Awesome. It's been phenomenal. Great. Yeah. So this is fine. Now there is one problem here, since we can actually say that. What if this split has split the data the other way? For example, what if this split actually showed that everything to the right is red and everything to the left is blue? What if this was that kind of split? What would be the accuracy of that kind of split?
The inverse, 25.
25%, absolutely. This would be inverse. So there is no even need to calculate it. It's an inverse. So we would use, for the future, we will use arrow to define the direction of the split. So if the arrow is up, then to the right is blue and to the left is red. If the arrow is down there, then basically you can turn it upside down and you can see that this is the way. So it turns out that we are actually working not with 4 splits here, but with 8 splits, right? So we need to consider the reverse split as well as we consider the original split. So we have calculated the split for the first split. We have calculated that the original split is 75% accuracy and the reverse split is 25% accuracy. It seems like a lot of splits that we need to calculate, but as Kenneth said, that it's not really like that, because we can just take a reverse and we can be fine with this. What about this guy? Lena, what is the accuracy of this split?
50-50.
50-50, it's like tossing a coin to your witcher. It's 50-50. What about the reverse split?
The
Of
same.
this? Yeah, great. I don't, you know, I was just trying to mess up with you and hoping that you will fall for that, but you didn't. You absolutely didn't. Oleg, what is this guy?
25 and 75.
Absolutely, absolutely. So this one is 25, this one is 75. Good. Whew, that's very nice. Igor, the last one left, which is this guy. So what is the accuracy of this split on both sides?
The same.
The same as what?
Is 50-50.
Yeah, it's 50-50 as well. Good, guys. You're doing great. I'm super happy. Is that okay? So now we have evaluated all the splits. And what happens now? What happens now? Lena, what happens now?
We need to choose the best ones, please.
Yeah, we need to choose the best one. And which are the best ones here?
75.
75%, yeah. So the second thing that we do, we choose the best one. And can't see the difference between slides. So what is that? Oh, okay. Which splits are the interests? So these are the best splits. How do we choose? Kenneth, that's a question for you. What's the way? How do we choose? How do we choose, Kenneth?
How did we choose?
How do we choose? So we have two splits.
Yep.
What is the way to choose? How do we choose? They are the same. How do we know which one to use?
I mean, it doesn't, essentially it doesn't matter. Ideally, we'd use both. But you know, so
Ideally,
do one first, then use the second one second. Do them in sequence.
But let's say we need one. Let's say we just need one here.
My instinct would be up 75, but I don't have a reason for that.
Okay, fair enough. Lena, what would be your take?
The same, like, but we can choose two, not?
We can choose two, but we need to first choose one. So the decision tree algorithm works this way. So we first choose one split, and then we go into one of the sides to make another split. And then maybe we could end up having the same split. That's fine. But the algorithm is like that. We first choose one, and then we go on into one of the parts to choose another one. So we need to select just one split here.
I guess I picked the first one because it's, as you step upward on X1 from 0, it's the first one you come to. Like
Okay, but you're an algorithm. You don't have personal preferences. So how do you?
No, but the algorithm is starting from 0 and stepping up. You know, so that's why I picked the left-hand one.
Maybe could be implemented the other way around as well. But what's the procedure here, Simon? What do you think would be the way to decide?
Just first.
Just first. No, you toss a coin. You basically you select it randomly. This is so when we had a discussion, remember about fixing this the seed, and you were asking about where the stochasticity comes into this kind of algorithms. So this is exactly where the decision tree algorithm performance, the final performance, is actually influenced by the decision by the stochasticity, right? So you can actually get different splits because they may have different performance values. So yeah. And now what is the break? So let's have a break and come back at 12. Yeah, that's the thing. And yeah, so see you very soon.